Just like one bad landing away from covering it all up. Just
You know the guys who are like walk the beaches with those metal detectors?
Yeah.
Do you think they're super jealous of this right now?
Oh yeah.
oh, that's gonna be us in a little bit.
Oh yeah, that's right.
We're gonna be going around with a magnet.
What,
We're gonna be those guys on the beach.
do you wanna explain that a bit more? Do you know more about it?
What? I don't know a lot about it. I know that we're going to like a meteorite site.
Yeah. So we were there a couple of years ago with working with, I think his name is Mark Fries, who's
Yeah.
has the coolest job title in the world. He's the cosmic dust curator for NASA.
Whoa.
And
Yeah.
How do you get that title?
exactly. So there was a meteorite that fell to the.
Uh-oh, zip tie's going in.
Is it?
Yeah. Sorry.
No.
That's good.
I don't know enough about the pathway to know if that's.
But yeah, but apparently.
It didn't go in the end. It's still there. You can see
Oh,
it.
is it? Okay.
Yeah.
Rearranged.
But sorry, I want to hear more.
From what I understand, they came by and they thought they didn't get anything.
Yeah. So we came out 2 years ago. So the background is a bunch of people saw a meteorite kind of fall from the ocean and fall from the sky into the ocean. Based on that, they went back and checked the Doppler radar from weather, and saw the signature, traced it to the surface of the ocean. We went out to that location, brought the ROVs down to the seafloor, and we're essentially hunting for bits of that meteorite. And we had some various methods, but one of which was using an array of magnets. And I think they got little bits of that were promising and that were indicative of, what we were looking for. So we're going back to that site, and the ROV team, including Michael, has been building a magnet array. And if you want to continue, I think we're going to be using the dredge for that. Is that right?
Yeah, that's correct. We're going to be setting up an array of some magnets on the exhaust, so that when whatever we pull through goes out, and then it has to pass through
Yeah, it's pretty cool.
the array of magnets. And then I also think we're onboarding electromagnet to turn on and off, so you can go under through and put it in the bio box and then turn it off.
Whoa, that's pretty cool.
Yeah, so and then the hope is that we find a bigger chunk, obviously, but
Yeah, and I already called dibs, so.
On NASA already called dibs on
Mark's not here. It's first come, first serve. Okay, and I called it.
Inside of the car.
I have it. Exactly.
It's like, oh, NASA, we only found this one small rock. It's like, really? Because in the footage, it looked like you found a whole bunch. No.
No. Objects in the camera seem a lot larger than they appear.
Yeah, I think it fell off the sub on our way up.
Oh, and by the way, those pieces are radioactive.
Fell off the back of the truck.
Worth it.
So that is an element of our next cruise, but not the main.
Not the majority. Yeah.
Not the majority.
I think it's only one. Is it one dive?
Yeah, it should be, as far as I know.
That's pretty exciting. So do you guys have like another organization that you're working with for that next stint? Or is it now, like after you drop us off, you guys just go do whatever you want?
There's a few collaborators, one of which is that NASA for that, I believe. Yeah. And then there's Olympic Coast National Marine Sanctuary. We'll be working with them, and also Oregon State University with Andrew Thurber's lab.
What are they looking at?
Methane seeps, I believe.
There seems to be something here.
It's looking like the sediment's a lot easier to vacuum than the glass.
Yeah, the glass seems to...
Like weighty.
It's a bit heavy.
Yeah.
makes sense. It's heavy.
Yeah.
AJ, do you want to tell the world what we're doing right now?
You want me to say?
Or whoever.
Yeah, so this is a caisson, and somewhere deep inside, under this ice cream swirl, is a broadband seismometer. That's one of several of our seismometers that is part of our network for the early earthquake warning system. I think they're also connected with seismometers all over the world in order to help, track earthquakes as part of a global network. But Ocean Networks Canada is also involved with operating the early earthquake warning system for British Columbia and Vancouver Island. So we have seismometers at many of our observatory sites under the ocean, as well as a whole bunch around Vancouver Island, like actually on land as well. And they all communicate via satellite or this networked cable to help us quickly locate earthquakes and then send warnings to the different agencies that can then pass those warnings along, so that the people of British Columbia get extra time in case of an earthquake, or I guess the fear is a very big earthquake that I believe we're due for, living on an active fault. That's always a concern. So this seismometer is no longer providing us with data, communications, so we're going to dig it up. We're going to remove it from the hole. The plan is to then fill the hole with just some bead bags to sort of preserve it as empty, so that it doesn't fill back in. And then we're going to come back with a different ROV on an upcoming cruise, and we'll deploy a new broadband seismometer. And
when they're deployed, are they covered up, or is this just covered up because of time?
No, so we do cut open those bags of beads in order to fill in all the gaps, and that's why this hole is full of white glass. This is what's actually in those bead bags that we're carrying around.
Copy.
And I mean, I'm pretty sure that the idea is to just really, you want to really sort of bond the seismometer with.
Wow. That just happened.
Yeah, it seems like we're.
Seems like it prefers an aperture, but then it just starts sucking in just water, and then too little and it's clogged, and too much doesn't get anything. As far as like the size of the water, but then the water opening. Heavy little beads.
How many seismometers are on ONC's network here?
That's an excellent question. I'll find out. There's a lot. I want to say.
It's not taking it.
Maybe in the order of 40, but let me confirm that.
And do you have to regularly change them? Like, is this kind of sort of standard practice that at some point it wouldn't be working and you need to exchange it?
I don't think we would call this standard practice. I mean, with all instruments in the seabed, we have 17. I don't think that's right, Sarov. We have 36 land-based sites on Vancouver Island, it says right here. 36 and 8 seafloor sites. Maybe we don't have all of those installed yet. But our early earthquake warning infographic is pointing towards 40 to 44. Where did you get 17?
I just looked up our Oceans 2.0 database.
Oh, but those are specific to the Geralt broadband seismometers. We have Titans. We have a whole bunch of other instruments that get used as part of this.
Right.
But I guess we have 17 of these particular type of seismometer. But no, I think this one failed earlier than we would expect. I don't think we want to be going and replacing these that frequently. I think the idea is that they last many years. I imagine that we're going to have a harder time with some of our subsea infrastructure, as it's a little bit more difficult to manage than the sites that we have on land.
So did you say you had something like 40 sites total on
Yeah.
land and on the seafloor?
Yeah, it looks like we have 44, 36 on land and 8 on the seabed as part of our network. 105 earthquake sensors between those 44 sites, and 23 earthquake detections by early earthquake warning systems since it started in September 2018.
Is there
wow. It's pretty young.
Now this is just me not knowing
This article was written
about the like just sensors on it, but like what's the sensitivity range? Like how big and how far does something have to be away for it to get picked up?
Oh man, you are asking not the right person. Maybe, I don't know if some of our scientists are here on SciChat, maybe Martin.
Or is it depending on the type of wave that's coming in?
Yeah, I mean, I think I'd just be reaching for my first year geology course if I tried to answer any of these questions.
I forgot what types of waves there are too.
Yeah, P waves, S waves.
P waves and S waves.
Yeah, there we go. So I remember some
Is there
things.
another one? Maybe
We
not.
have a really cool earthquake data dashboard that shows all the earthquakes that we've measured and their sizes and where they are. So Fiji, Russia, Japan, Chile, Philippines, these are all earthquakes that have happened in the last few days, it seems like, that are coming up on our scales. And so we can obviously measure earthquakes all around the world. Those were magnitude between 6 and 7. We had a 4.2 on Vancouver Island late August that was picked up. So it looks like maybe some of the smaller ones have to be a little closer to home.
I'm also very curious of like what is the calibration factor on it? Like what does it get set to?
Yeah, we can hear you, Ian. Yeah, you want to talk about seismometers?
No, we can't. You're just coming from the lounge.
Oh, sorry. So I'll come off SPL then.
Yes.
That's it.
All right, sorry about that. Just had a little call from upstairs. We were talking about sensitivity of seismometers.
Yeah.
I'm going to look them up. Yeah, Dan, if you could try to get those beads not back in the hole. The ones that are coming out of the hose.
Yeah, I think he's trying to dump them outside.
Trying to go outside the hole? Yeah, thank you.
Do you want me to zoom out, Dan?
Sure. Does the vacuum have a suck and a blow setting?
It is indeed a Venturi. It is indeed a Venturi vacuum.
So you can reverse direction?
Negatory.
Negatory. All right.
Like on a Tritech zip pump you can, but those are big machines that you find on 100 horsepower ROV. It's not really applicable on a science vehicle. They don't work too well unless they get, they want 20 or 30 gallons a minute, some crazy thing like that.
Want me to zoom back in, Dan?
Sure.
Okay. A minute.
Here's a quick fact from our early earthquake warning press release. Primary waves, P wave sensors, detect the first movements of the Earth's crust when an earthquake occurs. These first non-damaging waves are followed by the S waves, which cause the majority of shaking. The ability to quickly detect the P waves can provide seconds of advance warning before the arrival of the S waves. The effectiveness of the detection tool depends on having enough sensors and reliable communication infrastructure to get accurate information out quickly. So I think generally that's how this works, is that we detect the P waves, and then we tell everyone that an earthquake's coming, and they have seconds to respond. Seconds to tie back their furniture. Keep off the bridges.
Yeah, big stuff like that.
Trains slow down.
That's interesting.
What's that?
That it actually picks them up after you bury it.
Yeah, it seems like it's happiest when it has like the smallest.
It's well,
smallest opening of just
because it's a water
yeah,
suction.
I
I think it has to do with
Doesn't like that.
the pressure.
It needs some amount of flow for the Venturi to.
Right.
Somewhere like that.
Yeah,
Little.
seems like it.
Hot mic.
Well, we're definitely making progress here. I'm pretty excited about it.
I'm curious because normally we'll see the exhaust flow out, but we don't really see a mound or anything. But with these denser glass beads, I'm curious if there's just a little pile of beads behind us.
Yeah.
When we're done.
Yeah, we'll have to go.
I'm actually concerned about
turn around.
It's just staying in the hose.
Can we? Is that like? There's one of the Herc cams. You can see there's white on the ground. You think that's the white beads? I don't have the name. I can't see the names of the cams.
The one with the line coming out. Actually, yeah, I guess you can see it kind of.
The second from the right.
Yeah.
Second from the right.
It looks like it is light on the white beads, but you can see some of the white beads popping out there. That's the starboard side, though. Does that make sense?
So that could be that white mark we see on Argus that's what we were talking about. Has been there the whole time.
Yeah.
It's just the reflection of the light.
The light's hitting it, and it's lighting up.
It looks like more than
But why
a
is it all?
reflection, though.
Yeah,
I
that's-
don't
There's
think it's
something
the
white.
lights. I think it's maybe old glass.
You can see
Yeah.
that it crosses a boundary.
Yeah, I guess
Yeah,
it
for
is.
sure.
The shadow.
It's the light, yeah. The
It
light's
could be from an old
making
bag.
it.
It's definitely not from suction. Why glass and not actual like sand?
Why glass and not sand? That's an excellent question. Could be that it's heavier. It's like heavy enough that it'll actually go where you want to put it and not create a big dust cloud.
My understanding was also is that the uniform size of the beads.
Oh, you can get more precise of a.
Yeah, and the roundness. But that was just from listening in.
Yeah, well, no, this is, I don't have any extra knowledge. I'm just guessing.
Yeah. Something about their compactness factor.
Yeah, I guess if you had like a bag of sand, it would change the amount, the weight once it got wet.
Yeah, it might also sort of pack
comes
together
out,
when it gets
and then
wet,
packs,
whereas
and
this
then-
like would stay separate.
Yeah. Different types of sand or whatever.
But like in theory, once we got past the top layer of, you know, like the regular Cascadia
Sputnik.
dirt.
Yeah.
Oh, yeah, look at lights.
That's crazy.
Is that a T-4? I don't know what that was.
Once we got past the regular, like once we suctioned out the regular dirt, now if we went with a shovel, would we still stir up a lot of sediment? Because it's all glass.
Mm.
Oh, that's a good-
Maybe when it hit the other sediment, but I don't know.
I guess the concern is that you'd bang the instrument.
Yeah.
So we got the instrument.
Yeah, well, you're telling me to be very careful.
Yeah. Be careful.
Now slam it with the shovel.
Be careful, but
But here's a
Go.
shovel.
here's a shovel.
You know what? Let's really get this out of here. Here's a stick of dynamite.
You know, if we had a scuba board, we'd be trying it, though.
Oh yeah. Not a question.
You can see the stream of the exhaust in another cam floating up. It seems.
Where?
Like a little vortex.
Oh, yeah, that's the
second
thruster
from
That's from
left.
the starboard. That's from
Oh, that's the
thruster.
thruster.
Yeah. We occasionally get those little dust devils from that.
That's pretty cool.
Yesterday by the whale fall, it was strong.
Yeah.
The vortex. Herc looks so content. Just vacuuming.
Herc has become a Roomba.
Yeah.
Is there a specific array structure that these sensors are set in?
What do you mean?
Meaning, like, are they set up in a like, oh, we'll as long as they're X amount of meters apart, it's fine, or are they set up in a specific
Pattern is.
pattern, array pattern?
I think we're looking for coverage. Like if, this is just me guessing, like looking at the dots of where all of our sensors are on land, is that they're sort of spread fairly uniformly across the island. So I think we're just looking for as much sort of evenly spaced coverage as we can get. On our subsea network, it's a bit tougher because we only have nodes in very particular locations, and we only have junction boxes in particular locations, so we just kind of put them, we have less control over where they go. We
Gotcha.
just put them at each junction box, essentially, because that's kind of all the coverage we could get that's available to us. We're not like running super long cables out to try to, you know, make a grid on the ocean floor. It just doesn't go that far.
Did you say that there are other similar versions of these that use satellite communications?
Sorry, Megan, I can't really hear you.
Oh, sorry. Is that better?
A little bit.
Okay. Did you say earlier that there are other similar versions of these that use satellite communications instead of cables? Or is that just on land?
Yeah, well, on land, yeah. So our on land sensors, a lot of them are in remote areas where there's not cell network or anything, so they're using satellite communications as their form. Those, a lot of those on land sensors were really neat from what I hear from the early earthquake warning team at the Marine Technology Sensors. You know, really remote places that you'd have to get helicoptered into, and then they'd go and they'd sort of pour the concrete and mount all the instruments and set up the satellite dish. And so it was really a lot of construction work with not a lot of resources. A lot of Vancouver Island is still very remote.
Seems to be jammed up or something.
Did you adjust the hose?
You want to turn it off for a second? I just repositioned a little on it.
Yeah.
Since we've disturbed the seabed, it's...
We're all suctioned in.
Can you turn off the porch light for a minute, Mike?
Copy. You want the down LED off too?
Oh, that's good now, I can see. All right, you can
Start it
go
back up.
back to 100. It's full jam, is it?
Yeah, I'm at 100.
Might need some hose extensions and retractions. Jammed up.
It's like perfect.
I just mean like adjusting so the sediment flows if it's caught up in there.
Oh, yeah. The old in, out, in, out.
Yeah. I don't know if it'll work, but.
Seemed to have moved forward again. Zoom out for us, Megan.
Zooming out.
Thank you. It's definitely on, is it?
Yeah.
100%.
100%.
Try cycling it.
It's on. 100. Want to look at the gauges real quick?
What's that?
Not that one. Not that one. This one.
Got any more tilt down in Argus?
I have some, yeah.
Maybe Rennie can move the ship away a little.
We're, I think we're zoomed in on Argus, no?
We are zoomed in a little, but.
You want to zoom out on Argus? See where we're at?
Or do you want to see the exhaust?
I do.
You want me to zoom in or zoom out?
Let us get settled out here first.
Copy.
Looks like that's our piled out on the former port side of Berg.
It does. Maybe it was clogging the exhaust.
Oh, I see what you're saying.
Might have been piled up so high that it was backing up.
Yeah, yeah.
Oh, it's pretty high.
Good thought.
A lot of dirt.
I can spin a little. It's still on, I think, right? Yeah, so.
Is it on at 100 now?
It's still on at 100.
Roger.
Try to get the smoke out of the way. This dust cloud.
Wildfire smoke.
I'm not seeing any go in. I can cycle it again.
Made our own wind.
Say again?
So we made some of our own wind.
Yeah.
Kind of looks like maybe something's coming out of the exhaust quicker than the dust around it.
It does. But I have the some forward thrust on too.
Yeah.
Would you like me to cycle?
No, I'm going to leave it running full blast there. And clear out anything that might be in it. Okay, Megan, you can zoom in a little if you want.
Zooming in.
That's great, thanks.
Sure. You happy with Argus as well?
Sure.
Sure to zoom in or happy where it is now?
You can zoom in if you want. See if we see any exhaust there.
Okay.
Not looking too promising.
No.
No.
Of course.
A little bit.
Of course.
Every time.
We've been steady for a while. No, I'm not seeing much of exhaust. It's actually starting to set off.
Zoom out for us, please, Megan.
Zooming out. Full wide.
Roger.
No, it does look like it's coming out now.
Does that make a difference?
You can
going
see
in and out?
you can see a stream. Yeah. Stream of exhaust. Maybe you can't do it on like big turns, I guess? Maybe? Yeah, because that does look like exhaust.
Wow, learn
From
something
the-
new every day. I didn't know I could turn the wrist while the arm was halted.
What?
Huh.
The more you know. Yeah, we're definitely getting exhaust. That's definitely from the two.
Yeah,
from the
maybe
nose.
it's just like all. It's got a
Here-
bunch in there. It's trying to exit.
Here's the beat.
Yeah, it's like pushing out quite a bit out.
Yeah, maybe we just wait that out.
Got too greedy. Oh yeah, it's freaking rocketing out of there.
Yeah, I think we just got too greedy and it kind of like clogged
We
up.
definitely got too greedy.
It's flying out of there.
Yeah.
Good to know it's still working. It just needs to
Yeah, that's
process
actually
that.
pretty good, yeah.
It's a good shot in Argus.
It is shooting it out
Herc looks like a
like a hot rod.
Volkswagen Jetta TDI diesel.
If only Herc could run on sediment from the seafloor.
I think, yeah, Herc runs on glass beads.
Amazing, it's still coming out of there at that velocity.
It's kind of is that how it was with the old engine? With Thor?
No, it was worse.
Imagine, I don't know why. Never mind, that's dumb. Dumb thought. Just thinking about Herc on the cover of his glass bead cereal box. It runs on it. In another world, maybe. But
Unbelievable, it's still coming out.
yeah.
It's coming out strong. I mean, I'm not tripping. That it does look
No,
like the exhaust.
Yeah.
Yeah,
Definitely the
It's
exhaust.
not like
for
the,
sure.
the
That's not a normal thing for Herc.
Like,
No,
see
we
that?
stuck the,
Is it just pulling it through from the Venturi though?
yeah, I think we basically stuffed the hose full of glass beads, and by doing the old in out here, it's
I think they're so heavy that it doesn't go through the same way as sediment, so it sits in there a bit.
it takes longer.
We can't suck up so much that it just fills.
the good news is we are getting exhaust.
Yeah.
So we're gonna have to do like a vacuum transect, where it's like 2-3 beads a minute.
Are you?
Seems to be thinning out a little
Does,
there.
yeah.
Yeah,
Yeah, see the trail on the seabed there?
yeah.
Yeah.
So it definitely
A little glass bead mark.
vomited out some glass beads there. See if it's working now. Oh yeah,
There we go.
Oh yeah, look at that suction
we're
power.
in business again.
You want me to zoom in?
How long does it take for that to go through? Almost instant.
Whoa.
Yeah, and that
Okay.
stuff makes a bigger cloud, right?
Yeah.
Like you can tell what's glass and what's sediment.
It's
Yeah,
finer
so
particles.
well, that's encouraging. We can clog it and clear it.
Now we can see you can find that sweet spot of how much you can take in versus how much comes out. Now that we're behind her.
It's a better angle now. We can. Okay. You want to, if you want, you can zoom in a little, Megan.
Zooming in.
I'm just saying, man, they could put like a giant white sticker, and we can color balance Argus.
I'm for it.
Okay.
Be a little tricky though.
There's the exhaust right there. So it takes a few seconds, but
So I think maybe the key is to keep the nozzle out of the,
Yeah.
usually with the Tritec, they're a Venturi jet as well, and if you stuff more than about a quarter of the nozzle in the mud, it does the same thing, basically stops working.
seems to be happiest right there.
And those have a mechanical valve that you can reverse the Venturi, which then kills your visibility for days.
There it goes. It's like coming, like the glass is coming out in like chunks, like just spurting out. It's crazy.
I did one of those make work things there for us and pushed the pile up with Move the vehicle.
I wasn't going to say anything.
What's that?
I wasn't going to say anything.
I'm having so much fun there.
Add some more. Effective right there.
It's a pretty steady stream on the exhaust now, is it?
Yeah.
SPL test.
Copy.
Yeah. Sounded like
That was Ed.
Dr. McNichol.
Indeed. He's been a ghost on my computer.
He lives in the system now.
He's downloaded into our racks.
He's downloaded. Stuff goes so much quicker than the, oh, there's that tie wrap there.
Turn it off, Mike.
Off.
Thank you. Huh,
Doesn't
that's
look very
interesting.
off.
Okay, back on.
And it's off.
Full power.
Full power.
We'll look for it on the other end.
A little latency there.
I think that was it.
See if you see the tie wrap come out the exhaust.
I'm also very surprised it's not just billowing, like and covering Herc altogether, like it did in the other location where we tested it.
Ah, the avalanche.
The fluidity of the glass beads makes it really easy for the slope failure, so it just kind of goes right to you.
Yeah. Very nice to watch. We should fill this. Fill this up with different colored beads next time.
Like sand art.
Yeah.
Each bag is different layers. I've been to an art fair before.
It reminds me of like elementary school.
Yeah.
Sand looks crazy. That's
Yeah, right?
What an
Where
escape.
did he come from?
Man, he's going to have a story to tell.
Wrong place to set up shop.
Probably good practice to pause every once in a while, watch all the exhaust go out.
Let it clear out for a minute there. Watch Argus exhaust.
Yeah.
Exhaust cam.
Smog check.
We should move one of the cameras for the meteorite survey.
Yeah, we should probably move the butt cam over.
Well, we need the butt cam. Maybe, yeah, I don't know.
System really needs one extra that you could move all around. So.
Suppose you could, if we weren't doing much starboard bio stuff, you could take one of those away.
Yeah, I think so. Still rocketing out of there, or is it?
Yeah, it's still coming out.
Yeah. As more comes out, the suction
Slowly comes back.
yeah.
So, AJ, at some point, do you want to expose the handle and yank that thing out of there, or?
Yeah. Yeah, I think once we see the handle, we should.
What's that?
I think once we see the handle, we should have a go at it.
Roger. Any idea what side the handle's flipped over on?
Absolutely no idea.
It's funny as so it wasn't sucking at all in that position.
Yeah.
And just holding here,
it just needs to clear out.
What's really cool is when you see like the dust clouds sort of come pass by and then just kind of get sucked in. Almost string-like. Oh.
This was installed in May 2014.
Oh, back at full blast.
Oh, what's that? Bolt in? Oh, a full-on bolt. We got some suction power back now.
Oh. Uh-oh.
Oh.
We lost it.
Oh, it's coming.
We had a big clump.
Yeah, there's a clump in there. Might need
So it's I'm gonna have to wait a little bit.
See some orange there. Can you move bubble so I can see more of the. Yeah, that's tilt up there a bit. Cheers.
one somewhere.
So it looks to me like the handle was straight up when these bead bags were cut over it.
Was the handle orange?
The handle was orange.
Well, I think we see that in brow.
Yeah, that orange tape should be the handle.
Okay.
You think so?
Yeah.
Oh. No suction.
Well, there's enough of that sticking out to grab.
Yeah, I think we can go for that pretty carefully.
What's that?
I think we can go for that pretty carefully.
Yeah, I think so. Okay, Megan, can you zoom out for us?
Zooming out.
Thank you.
Full wide.
You want me to turn it off?
No, leave it on.
Oh,
See
so
if it'll
cycle through. Yeah.
clear itself. Try and park it out of the mud here. Probably won't stay there. If it falls in the mud, you can turn it off.
Probably okay. It'll just suck some mud away and then make a hole for itself.
I hate it when that button doesn't work.
The halt or the grip?
Either one of them are working. You can probably leave it go there. As long as you see a jet coming out of Argus, we'll leave it go. Okay, show me the handle and bubble.
You are directly above it, it seems.
What's that, Ben?
You are directly above it, it seems.
Appear to be. You zoom in on bubble a bit. That's good. Okay, zoom back out. Go ahead and turn that dredge off now.
Copy, it is off.
Roger. Oh. Okay, zoom back in on bubble.
Sure that's the handle?
Yep, pretty
Yeah,
sure.
it's just
Or is that just like
the
tape?
ripped
Just
off.
tape.
Okay.
Yeah.